Hello, everybody. Hey, wait a second. Now, can you hear me?
Yes.
Yes.
Yes. Hey, I'm waiting for Edu setting up everything. Give us a second, please. Just 5 minutes and we start, okay?
Hello guys, how are you? Hear me well?
Yes.
Hi, yes.
Hello. So sorry for the delay. We are setting up the new class setup. So for now on, we will. Santi, sorry. We will try to give all the lectures from here, and in this table we have a rig on the top. So if we are doing something hands-on, we will have another camera that you will look and be able to change the camera to check everything nicely. So, Santi, vamos a cerrar la puerta. Just closing the door. So, did you have time to play a little bit with Grasshopper? No,
Nope.
not at all. No. Let's see if you remember a little bit the key concepts from the other day. Screen two, share. So let me. Okay. So for the ones that don't remember where to look, well, the information where it is in the main repository that will have all the documentation for Fab Academy and MDF. So I will share again the link in the chat. What is the chat now? Sorry. Okay. So if you go to clubs, make club. Did you have a little bit of time to read a little bit the guide, the introduction is like the lecture. So we have the Grasshopper Start class, and this is the file of the class from the other day. And these are the key concepts that we went the other day. I don't know what this number is here. I will change it. So we have the interface, what is the parametric design concepts, parametric definition, and Rhino Grasshopper bridge, that we made the link between the points or the lines of Rhino into Grasshopper. And this is the working file from last session, and these are the clean scripts. What is a clean script? Let's say is the same information that we have in the same file that we did during the class, but slightly cleaner. So you can have all the little concepts that we went the other day and in small groups. So you can see how to create a series of numbers, how to create points, how to create a curve based on the lines, how to create a series. Like for example, remember we went a little bit on how to create a sign and other concepts. Like for example, how to create two different lines like these ones and connect them. So today we're gonna go slightly ahead. Let me close this folder, open this one. Yeah. So today class, obviously there is not a file yet. We want to do it. And we will go over some key points. What are those key points? What is the list and the list concept? We already went through them last day, but it's really important to know how to this, understand the concept, so I will repeat. How to operate with lists, geometry as a list, and how to make geometry transformations. So today's session is going to be divided more or less in two big parts. One that is going to be the main like lecture, let's say experimentation, that is really important that you try to do at the same time as I do the scripts. Don't worry if you get a little bit lost because we will have time in the second part of the class. So I will explain the concepts of what is everything, the list, how to transform, what is a geometry as a list, etc. And there is that there's going to be those scripts called like grow, scale, rotate, list, geometry list, grow, scale, rotate surface, displace, geometry, and connect. So we will reach until almost the last one. And you can open this one or you can not open it, but the idea is that you try to repeat this script and you try to do it yourself. you will do it in groups. So we will go into breakout rooms, and you will try to find the logic to produce a similar output as this script. It doesn't have to be mandatorily this one. So how this script looks like? Actually, let's open to see where we want to reach at the end of this class. What is the goal of the end of this class? This is nothing. We can actually make a new file. Make a new file, yes. So the goal is that you can produce a geometry like that. And a geometry like that, that can actually change its position and its variable. Let me change, where is the, this is the key point, no? Yes. So if I change the point, this point, the geometry changes as well. So it's where parametric takes into account and how to create like useful scripts, not just fancy things. For example, this could be used instead of a point, could be an input data, for example, from a sensor that you are receiving the data through internet, and you want to have a live visualization, or could be, for example, a music 3D graph, or could be, I don't know, maybe it's a geometry that varies, depends on the distance of a person approximating to this building or geometry. That really doesn't matter. But the point is that this is data, and this could be data, and we are using just a simple point, and has some three values, that is x, y, z. Let's not get too crazy into this because it's the last part of the class, more or less from 1:15 we will go onto this one. So you have more or less clear what is going to be today's schedule? Yes. Okay. So let's go over the first file. Desktop, blah, 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 blah. Academy, look at docs, assets, clubs, club, corporate assets, one. So lists. I will set up bifocals. Bifocals is a plugin that just, you can see my screen, no? Yeah. Yeah, okay. So bifocals is a plugin.
Edu, are we supposed to?
Sorry?
Are we supposed to download any? Are we supposed to?
We have a lot of dropouts from your side. I don't
Yes.
understand really well what you try to say. Could you repeat, please?
Hear me better?
Jana, just try to. ¿Los plugins o los archivos? Can you try to just to put it on the chat? Do we have to download any files? No. The files are there just in case you get lost and you want to check it after the session. So the idea always for this session is that you try to do it at the same time as I do. Okay, so this is the file that you can watch later, but let's try to use as a guideline right now for the class. So I'm going to create a panel, let's say a list of data. What is going to be the data? Actually, it's going to be you. For example, Roger, I have set up a panel with Roger, and I want to create more people in this list. For example, Clement. Don't know if I'm pronouncing your name properly. I'm sorry if I don't. Jana, Morgan, Yasmin, Anais. I'm just the names that you show in your chat. I'm just typing them. Veronica, Jose, Chris, Tobia, Sergio, Santi, that is here. I think it's enough. So we have a list right now. This is a panel with data. This could be numbers, it could be names, as this case. This panel right now is not as we want to use a standard panel. Panels have two types of data. Let's say just a line, that in this case is good to see it like that, but you have multiple lines, you don't want to watch it like this. You want to right-click and say multi-line data. And now we can see properly what is the position of each line of data. So if you right-click on the panel, you can watch it as multi-line data. That, in my personal opinion, is always how you should watch a panel. Why? Because let's say you have write this Leo, and you click enter without willing to confirm. This right now has wrong data, but you don't see. But in case you have the panel in multi-line data, yes, you see. You have a line that is empty. This will create a lot of failures in your script. So you want to avoid that. How to avoid that? Just about visualization. If you multi-line data, you will be able to see, and you will be able to see that there is something wrong. So what is a list? Basically, it's an amount of data that is listed in order. Quite easy. We have always position number 1 is 0, because in mathematics, 0 is the first number. So let's say we want to, where are the list component parts? They are here, maths and sets. So list, we have all the list operators. This is how we can manage data. Let's say we want to take something, we can put something. Let's go for the simple one and the most useful one. That is list item. List item. This one work is to pull a component out. I will make it big because we don't need the visualization right now. So let's say I want to list one of the items. It means I want to take Jana out of here and just use, well, not use, like take Jana out of class. So in which position is from this list, in which position we are, list index is by default is 0. So it's taking Roger out. Let's say we want to take Jana, position number 3. We just set up a slider and we connect it. So now we can take Jana or Morgan or Jasmine out of class. Really easy. And this is important. Right now it's all your names, but in the next example you will see that we can do this with geometries. We can just select one part of the geometry, and we do it by listing items. For example, let's say David no, cool item. We want to, for example, insert items. For example, Leo just arrived late to class. We want to merge in the same list. Let's put a panel at the end. So we want to insert what item? Leo. Leo arrived late. But Leo arrived and is going to be in which position? Actually, Leo is a little bit aggressive and wants to be the first one in class. So it jumps to the first position. But let's say Leo wants to be in the second position. So we can choose where Leo is going to be in the list. We can insert something in a list and we can state in which position we want to insert. So Leo came late, but now is the second one of the class. What else we can do? We can get the first and the last ones of the class. We can just select. We want to know from this list which is the first value, in this case the first person, and which one is the last one. So we have Roger is the first and Santi is the last one. So let's say we want to replace, or room is, because COVID thinks we can only have 12 people, and Leo again wants to fit in class, so it needs to push, for example, Santi out. We want to kick Santi and replace it by Leo. So now this is replace item. You can state which element is going to replace. For example, can also replace number 9, that is Chris. We can shift the list.
I'm totally lost.
Sorry, you got lost, all of you. Okay.
Yes. Yeah.
So let's start since the beginning. So we have a list of components, of elements, persons here. So what you want to do, let's consider these numbers. Like I'm just stating person because it's way easier than doing this, than using numbers. These right now are persons, people's names, but in general we use this with numbers. So a geometry, for example, a box has 6 faces. So the first face will be this one, the second face will be this one, the third surface will be this one, the fourth surface will be this one, the 6, 7, and 8. So a box, a simple cube, will have 6 faces. But it's way difficult to explain this when they are like, it's saying surface, 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 surface. So I'm just stating up this with names. So you can really see what we are taking in and out. So let's say we want to select someone from this list. We use components. For example, list item is listing, taking someone from the list. So we have the index. Roger is in the index Z0. Clement is in the index 1. Santi is in index 12. It means the position. What is the position of this component? In this case, is a person in this list. So we work all the time for when we want to produce geometries, we work all the time with lists. List of elements is a list of points, a list of curves, a list of lines, a list of surfaces, a list of maybe cubes or more complex geometries. But it's always lists. And we want to know how to operate with lists. So these sets are the basics list operators. In here we don't have like plus and minus. We can take in, take out, replace, select the first and the last one. We can reverse the list. It means we can change the order of the list. We can sort the list. We can split the list. Maybe from one data set, we want to produce 2. So the simplest ones is list item. That is, select someone from this list.
In the list itself is just a panel, right?
The list, this is a panel, yes.
Okay.
Maybe you explain why we use this.
Es para el ejemplo. This is a bottom-up approach. Right now, you don't understand why we use panels. But the next example, you really completely understand. So now you need to learn how to operate. Then you will learn why we operate. Okay? So it's important that you understand that we can insert someone in a list. We can have 2 lists and transform it into 1 list. We can, from a list, we can take some elements. We can take elements by the index, or we can just take by the first and the last one. We can also replace index, replace data. Why? Because maybe you have a box, but you want to change one of the points that creates that box. Let's do another operator. That will be, for example, shift the list. This is really common. What is shifting? Is move the list. So you see that the component is orange because has no data coming, and now it's gray because by defect a lot of components shift 1. it means move the list 1. So Clement is going to be pushed to the top. We are pushing how many? Let's say a slider. Let's put 1 into the slider. We push everybody 1. So Clement now is the first one. David now is not in the index 2, it's index 1. So we are pushing all the list up. And we are just changing. The first one, that was Roger, now is the last one. We can see it here. Because we are shifting 1. If we shift 2, now David, we are moving the index. It means the one that was index 2 now is index 0. We can also do other things. For example, we can reverse list. What will reverse list will do is actually will exactly flip it over. Oh, sorry. So now Santi is the first one and Roger is the last one. Clement is also at the end of the list and Sergio is the second one of the list. So we can produce, this is list operators. We can also partition the list. Let's say this is your whole class, and now because of COVID things, we can only have 6 people in each class. Now we are making 2 lists, actually 3, for this one class. You are have in 3 different rooms. Actually, Santi is alone. You see that here we have like 0, 0, 0, 1, 0, 2. So these are branches. So what the data looks like. So if we have a panel, let's say, I will use a scribble here. If we have just one class and we have data inside, in this case is 13 persons, we want to divide it into groups of 6. 1, 2, 3, 4, 5, 6. And this one will be divided another one into 6. 1, 2, 3, 4, 5, 6. And we will divide the rest. And here we don't have 6. What we have? We have 1, because we only have data to fill with 1 amount. So this component is dividing the list into groups of 6 until there is no more data. So we have this one that's going to be alone. You understood this part?
Yes, just one thing. What the component size? What is it? Where do you get it from?
This one.
Yes, that.
This is just a slider. It's a number slider. For example, you tap
Number
type.
slider. Okay, perfect. Thank you.
You can also type it as a slider. Number slider.
Can I ask you a quick question?
Yes.
I'm trying to put the names in the list, but I can't seem to edit my list. Can you just really quick make a new list so I can see how you do it?
Okay, for example, I can say like Leo. I usually just, how you can create is create panel by / or just type panel. So this is how you create a panel. You double click and you go inside. If you double click on it and you say Leo, enter, and you say Tobias, enter Marcel,
Okay, thank you. I
enter
got it.
Santi, and you click outside. And by default, it will be just white. It will not be a multi-line. So you right click and you multi-line data. Okay?
Thank you.
So we have a lot of operators, and we can extract components, we can split the list, we can partition the list. We can right now split lists. For example, what split list is similar to partition list, but we are stating where we want to split the list. we don't say how many people there is in each list, like here, but we are saying we want to cut in Jasmine. So we state 5 because we want to cut in Jasmine, and it will make 2 groups. Group until Jasmine and after Jasmine. So we can state where we want to cut. Maybe we want to take Roger and Clement out of class. Maybe no, we want to keep until Jasmine in class. So we can have multiple operators. We can also insert, list length. This is really useful. How many people there is in class? Right now it's easy. We can count. Actually, we have 13 people in class. But usually, a panel with geometry doesn't contain just 13 items. It has like 200 or sometimes has 1,000 of data inside a panel. So we want to know what is the total amount of data inside the panel. So we want to list length of the panel. What else we have? I'm just doing it individually, and here you have in the class file that is here, lists, you have all these files. Extract an item, list an item, insert an item, extract from the list, I'm going to explain one, divide the list in class, so we have one class and we divide it in 3. This is why we have the operators here. We have reverse the list, we have shift the list length, and the last ones that I'm going to explain now.
What's wrong if the panels are yellow?
Panel yellow.
So
It means the panel is yellow color. No worries. Like this is just my configuration. Of course,
okay.
You can change the color panel all the time.
Sorry, you explained how to visualize the components and icons for it.
Yes, last class. Santi wants to note that sometimes you don't watch the components like this, no? We went last time, and this is display. Display draw icons. You can watch the components by the text, split. I don't like it. I personally put it always in draw icons, so you watch them like this. This is visualization, and it's always draw icons, draw fancy wires, draw full names. So you can also watch the components with the full names. Usually don't state the full names because this component is easy, but some components are really big and takes a lot of space. We can also take someone out of class. So kicking out for class. So that will be cool index. It will be take, for example, I don't know, Veronica didn't practice his Grasshopper lessons, so we don't want to have it in this Zoom meeting. So we say that Veronica is not going to be anymore in class. So Veronica out. So we can choose who is in class or who is not. We can also cool index. Let's go these other ones. So dispatch is useful. Dispatch. So this one is widely used, and this is separating the group into 2 different groups. So we have group 1 and group 3. Why? Because maybe right now we are using a pattern, and we use, instead of saying the index, we use a pattern. It will be true, false, or true, true, false. What is true and false? Anybody remembers what true is in mathematics?
1.
Exactly. And false?
0.
Okay, so this pattern is going to send the first one, the even, to true, to the top, and the second one, the false, to the bottom. and we use a condition. So we can say a panel, for example, that is 0, 0, that is false, 0, 1. So each element that is in the third position is going to be sent to the top list. So Roger goes to the bottom, yes. Clement goes to the bottom, yes. 1. David goes to the top. Now we start again. Jana goes to the bottom. Morgan goes to the bottom. Jasmine, that is in the position number 6, is 1, 2, 3, and 4, 5, 6, 7, 8, 9, 10, 11, 12. So each one that is in the multiplier of 3 will go to the top. And this is a condition that we just made up by stating 0, 0, or 1, and could be true or false. But this is something that we can make conditions. Conditions like the ones that we're going to see in the next example. You understood this? Because it's what we're going to do exactly in the next example. Yes?
Just how did you create the condition list?
How do you create a condition like this? For example, let's create a series of numbers, okay? I will do it in numbers because it's easier. 5. I'm just typing numbers really randomly, okay? So, okay, I have this list of numbers. I want to separate them. The ones that are higher than what? Than, for example, 50, they need to go to the top. Oh, sorry. I want to select only the ones that are higher than 50. So we have a condition that is higher or smaller than. So if the value, sum of these values is smaller than 50, is telling me true, true or false. Yes, no, 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 yes, yes, no, no. For example, I can change this number by 500. Maybe it's better. So we have a few that are smaller than 500 and some that are higher than 500. So this component is just giving me if it's higher or lower. With this component, I can separate them because I have already 1, 1, 0, 1, 0, 0, 0, 1, 0. So I can separate them, and I can have in this list components that are higher than 500 and lower than 500. So this is, for example, a basic rule. And this is what we will create all the time. Did that solve your question?
Yes, thank you.
Perfect. I will keep the chat open just in case. So these are list operators, and we have simple ones, slightly more advanced, and more advanced. For example, these are branches. So for example, here that we have a panel with 3 different lists, this is called branching because basically this looks like a 3. So these 3 operators is to work independently from this, and from this at the same time. It's slightly more complex, and we will not go right now into that. We will work with simple lists, okay, all the time. Let's open the next file, that is grow, scale, rotate, surface. Geometry list. No, sorry, geometry lists. And we will create a simple box. I think is the easiest type. So let's go to box bifocals first, and let's create a surface. For example, let's create a primitive. For example, we can create a center box, a box that measures like I don't know, 100, 100, 100. Maybe it's too big. Let's make it smaller. Okay, it's a box that is 500, 500, 500. No, 444 or 555, really doesn't matter the size. So this box is made out of how many surfaces?
6.
6.
Exactly. How many lines? A lot of them. So let's, for example, deconstruct analysis. Deconstruct the bread. We want to take the top and bottom surface. So if this is a box, we can break it out in multiple components. For breaking up geometries, we use deconstruct a bread. Deconstruct bread will explode, kind of explode or component into a list of faces, 6 faces, a list of edges, and a list of vertices. That is the points that creates this geometry. Now you understand why we started with your names and not with a geometry. Because if we take untrimmed surface, you don't see the difference. But now we can actually, we know that we can select just number 3, or we can select number 2 here, or we can take the first and the last one. So let's switch off this one, this component, right click, let's not preview it.
Edu,
Yes.
if all the surfaces have the same name, how do we know which one is?
Wait for it. This is exactly what we're gonna explain right now. So there are different ways how we can select a face out of this geometry with the component in sets, list item. No? We can select, for example, the face. This is face number 1. It's difficult to estimate which one is the top, which one is the bottom. Let's put a slider between 0 and 10, just to select the faces. So we have this one, 1, 2, 3, 4, 5, and 6. Actually, it's the bottom one here. So here in Grasshopper, there are different ways of doing things. You know the bad, ugly. You know this movie, the bad, the ugly. So we have the same types. So we have, you can do it the bad way, the good way, and the ugly way. This will be the ugly way. You can do it manually. Grasshopper is not meant to do it things like that because it's useless. Useless it means in the way that it only works in this case. If you change the geometry, it will not work, and you will need to redo your script. So you are not creating any logic. You are just selecting manually, the same way you will create things in traditionally 3D modeling. So we want to cool an index. Let's say we want to select face number, you check number 4 and number index 6. So you can cool the faces, for example, number 4 and 5. So right now, you see why it's red? Because this is not a multi-line data panel. So now we have, if we switch off everything, we have actually cool, it means take out the top and bottom surfaces. But if I change this geometry, this will not work because the order of surfaces changes, depends on the geometry. If we have a dodecahedron, number 4 and 5 will not be the top and bottom surface. This is the ugly way. Actually, this is the bad way. Really, really the bad way. So we want to create a rule. This is what you should never do. I'm going to copy here, the bottom, and I'm going to switch off these things. Let's go with the same geometry, and let's do it the good way. So what will be the good way? Is establish a rule. What will be the rule? For example, these are faces. We want to take the top and bottom face, no? So a face, a surface, has a normal. It means a vector that points out the direction of the surface. If we have a box, all the faces have normals in different direction. Let's say the back one also follows the other one, and the bottom. Each face has a direction of normal. So we want to, for example, take the ones that are vertical. It means the z vector. So if we measure this and the angle of the vertical, the normals that are equal to the z, we want to take them out. So it's going to be automatic. If we measure the angle between the z and this face, for example, is going to be more or less, no, actually no, it's going to be more or less, no, it's going to be 90 degrees angle. So in this case, it's not going to be, it's going to be false. So how we create conditions like this? So here we have what? Surfaces. Once we have a surface, we can also analyze the surface. This component, I never remember the name. Yes, evaluate surface. So we want to evaluate the surface to get the normal. Evaluate surface. That is, please tell me the normal of the surface. Right now, I know it's like, okay, how the hell I know that this component exists and give me the surface? You go to surface, analysis, and is here, evaluate surface. So in surface, you have to call the components to extract all the parts that compounds the surface. You will get what? The points that compound the surface, the normal, the u and v value. What is the u and v value? When you have a surface, why I cannot draw here? When you have a surface, you can analyze the surface. This is a rectangle. You can analyze the surface here, or here, or here. But a surface has a dimension, no? Has a dimension in x and y. But this surface could be positioned in x and y plane, if you look at the camera, in the y and z plane, or something like completely random in any position of the space. So x and y of a surface are not called x and y. They are called u and v. And you can, how to evaluate the surface is determining in uv. It means in which position of the surface. We want to do it in the center, no? A surface, this surface measures from 0, it means each face, to 5, because we have set up the size. So each surface measures from 0 to 5. If you want to pick up the middle, the center of the surface is what? 2.5, 2.5. No? It's easy. What happened? This is quite annoying. If I change this number, this will not work anymore. So what we do is we kind of standardize the surface. We're going to say that this is called reparametrization. The surface, the maximum is going to be 1 in each one. And the minimum is 0. So we're going to constrain the values. So if the surface is between 0 and 10, I don't care. I'm going to make it always, the maximum is 1. So it's going to remap the values to 0 and 1. So the middle point is going to be always 0, 5, 0, 5. So the UV value will be 0, 5, 0, 5. We can do this by setting up 2 points, or we can use an MD slider. MD slider, we have the sliders, number slider, and MD slider. What is an MD slider? It's two-dimensional slider. It's like two sliders in one. We can have 0, 3, 0, 3, 0, 4, etc. We can right-click and also change the values, but by default it's okay. So I'm gonna erase it and put an MD slider. So we want the middle point of the surface, and we select it. And we can see here that is choosing the point, but it's not the middle point. Why? Because we didn't state, okay, you need to reparameterize the surface. You click, right click, and it's reparameterize. Means now it's from the bottom to the top, because the maximum is 1. So it doesn't matter the dimension of the surface, it's going to be always with an MD slider, we can always go all through the whole surface. I know this is slightly complex. The first steps in this kind, understanding these concepts are complex. So do you really understand this part?
Could you repeat how you reparameterized, please?
Yes. Okay, so you have the surface, and you want to say that the surface, let's say, measures virtually between 0 and 1, not between 0 and the maximum value of the surface. So if you go to the S, that is surface, is the input data, you want to reparameterize it. So this, right-click, reparameterize. You are actually not changing the geometry. You are just making equivalent.
Okay, thank you.
So now we have the normals. You see, we have the normals of each one of, of each of the faces. So the first face is minus y, because it is this one. Second one is in x, y, x, z, and z. Yes, we can see is the vector of each one of the faces in y, x, z, minus z, plus z. So we want to measure, let's move these things. We want to measure the angle between these vectors and the unit z, that is the vector z. You just type z and you will see the vector z. Unit z is a vector. So we want to measure the angle. You measure the angle between or you can do it the opposite, between one and the other one. So the measuring angle will be what? What is this? Welcome to Grasshopper. We don't work in degrees. Grasshopper works in radians by default. And it's annoying, like, at least for me. I have a background of architecture, not mathematics. So you can always change from radians to degrees. So you type degrees, and you will see the value, change it to degrees, just because it's easier. So now we can see that the value is what? 90, 90, 90, 90, because it's x, y, x, y, x, 180, and 0. Why? Any clue? The top vector is oriented to the top, it means equal to the z, and the bottom one is pointing down, it means it's the opposite to the z. So that's why it's minus z. So the value is 180. Yes? So right now we have already the angle. If we want to let's just keep going like this. Right now we have already a number, a list of numbers that we can operate easily. That is the degrees. So if we have a condition, if equal the angle of the surface is equal to what? To 90, it means it's perpendicular. We have a condition, true, true, false, true, true, false, true, true, false. So the horizontal faces are equal to 90. We can select only those faces. How we do this? We actually come to the beginning. Where are the faces? Here, no? So we can dispatch. We can select from these faces, make a group of A and B, and we move the component to the top. So all this will be our condition. From the faces, we take out the normal. We measure the angle between the vertical. We transform into degrees, so we can easily make the comparison, and the quality. If the vector are equal to 90, please give me to me. So right now here we have 4 surfaces, and here we have 2. In order to visualize everything, we're going to use the component geo, for example, that is just show me just this, and we switch off everything. So now we have established a rule. What we have done is take out of this list of 6 surfaces. Let me make it bigger so you can really see everything at once. So we have created a box. We have break out the box into its components, because it's difficult to take only the faces out if there is one unique component. So we have 6 surfaces. In order to extract the ones that are exactly in the z vector, we need to have a vector to compare the surface. So we take out the normal of the surface. It means the perpendicular vector. The normal, again, is if we have a surface, each surface has a vector pointing outside. That is the normal, the end of the surface. We have done by reparametrizing the value. So it doesn't matter the surface, it will be always between 0 and 1. And we are taking up the middle point. We could take any other point, but the middle point is just the average point of the surface. We have measured the angle. We have transformed it into degrees because the angle is in radians. And we have established a rule. If the surface is 90 degrees, put it in a different list. Okay, this is cool, no? We have established a rule. So what happened? This script is good, but it's ugly. Why? Because it doesn't work exactly as it should. Because we care that it's in the direction of the z, but right now we have opposite direction and same direction, no? Right now we are doing the opposite. We are taking only the faces that are not in the z. We want to take the ones that are in the z. Yes? So how we do this? These values have negative and positive. We can transform them to be, doesn't matter if it's positive to the z or negative to the z, to be absolute. So we use a component that is called absolute. Using a component that is called absolute, what we will do is make them absolute. It means without negatives. Now, instead of setting directly the normals, we will measure the angles. And you'll see now that we have 90, 90, 0, 0, 0. Does it change something? Now we can select only the faces that we don't want. if the face is equal, or let's say instead of saying equal, smaller than smaller or equal. Here, let's stay smaller or equal. 0, we will select these geometries. Why? Why we just made this a small change? Because what happened, maybe we want to have that the ones that are like 20 degrees onto the normal. Maybe we want the ones that are almost close to the z vector. We have the x and y. Maybe we want to choose all that are really close to the z, but they are not straight, completely straight. Why? Because this geometry, this works right now. I'm just changing to select the other ones, these ones. This right now is a box. What happens if the box is tilted? Or is not a box? What if instead of a box is a dodecahedron, for example? This is a dodecahedron. There is no face completely vertical, no? If we just change this, right now, let's hide it. Right now, it's not working. Why? Because we are measuring with an angle that is 0. But changing this, we can say, oh, just changing the slider, we can say that if the angle of the face is lower than 45 degrees, we can also take it. So now this script works with any other kind of geometry. Yes? No? Mind-blowing? So many webcams on. I don't know if everybody's in the restroom or... Hello?
Complex, I'd say.
Next time, I know.
I'm not sure.
I'm, yeah, I'm very lost. So I just think we have to put a lot of time.
I know.
Lost as well.
But I'm trying to get if you get the little concepts. So the point here is not to create something that works for just your geometry. For example, this box is to create something that could work for any geometry. So if you update, maybe your design changes, you don't care. Because you can always connect whatever geometry here and just measuring the angle, this one, you can select if it will work or not. For example, there's a moment we can select more than 90 degrees. It means all the faces. Kaboom. Let's go to one that is slightly simpler, okay? Yes? No? You want to go home and cry?
Yes.
Okay. Let's go to grow, scale, rotate. Basically, what we're going to do now is, you see, the scripts are not really long, but we're going to produce bases, for example, or towers. How to do this? Well, let's go introduce the concept of transforming geometries with lists. Okay? Bifocals. Let's start with something that is slightly more, something that you might be slightly more used to. So let's make a polygon. Polygon. Okay, we have a polygon. We can set up the position of the polygon, plane, that we can change the position with a point. Yes. Let's, for example, change to position 50. I don't know. Now it's here. We can move the position of the polygon. Let's change the radius. Let's make it big. We can easily change the polygon. We have other things. For example, number of segments. This is an hexagon. I want to have, for example, a triangle. Three faces, 4 faces, 5 faces, 6, 7, 8, like, I don't care. Let's stay with 5, just because I want. And we have fillet, that if the corner is sharp or round. In this case, I don't care. If we want to create this, how will be the logic of this? What is the logic of this? Anybody can guess? Okay.
You extend it along a
Surfaces?
Actually, if you just check, we are lofting what? It's an hexagon, that the next hexagon is slightly larger and larger, and each time it's growing up, it's also rotating a little bit, you see? And after having all these hexagons, we just loft them to produce a surface. So what we need to do? We need to scale them and rotate them and not have only one, but have several ones. No? Okay, let's start doing that. We have a polygon. We want to have like a lot of copies. No? We want to move this polygon. When you move a polygon, you need to state what you want to move, okay, the polygon, and the amount, the motion. That is a vector, in this case, in Z. Right now, you see that the vector is moving 0, 0, 1. So we have just move it once, no? Okay, how we can move several times? We can create a series of numbers. Series, this component creates numbers. We are moving 0, it means don't move. Move 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter, 6 millimeter, 7 millimeter, 8 millimeter, 10 millimeter. So if we connect, boom, we just move and create a lot of polygons. I think I'm gonna make it slightly smaller, so it's easier to see. Radius. So you don't see really well the gray, no? This gray. I'm gonna change the color because it's not really the best color for. Okay, in red. So now, for example, we have created. You say that component moves also keeps the original. It's moving but creating. Okay, component move, as is slightly particular in Grasshopper, moves the component. But if you move several times, puts everything in a list. That's why the first script we did today is the list one, because we are stacking data after data. We are stacking the first one and the rest of elements. Let's say we want to have more space between the polygons. How we do this? With the series numbers, we can change everything. What is the start number? 0. What is the step? We are growing 1 millimeter. Okay, maybe I want to grow 5 millimeter. Let's move this slightly lower. 5 millimeters. So now, for example, the space between the movements. Okay, we can grow more or less. Do you hear me,
Yeah.
guys?
now we
Yeah,
do.
just now we start hearing you.
A share screen too. Okay. Okay. I think you got lost. Is it frozen for you too? Yes. And just room reset. I don't know why. So, do you got this part of moving? I don't know where do you stop hearing us.
Right before you did that.
Okay. So we are creating a series of numbers that is going to be the amount of movement. We are moving 5, then 10, then 20, then 25, then 30, then 35, then 5. Or we can just change the spacing with a slider. So we can really change the total height. And we are creating in order to move, we need to state how much we want to move and in which direction. Right now we are moving Z, but if we move, for example, in X, we will move in the X-plane only, and we will create geometries like this. So right now we just want to move in Z. Okay. We have created a stack of polylines. We want to scale them, no? Let's change the size of each one of them. How we can scale them up? Scale. We want to scale all of them, and we need a center of scaling. Okay, right now if I change the scale factor is 0.5. Let's make a slider between 0, 1 to 10, for example. If I scale, I'm scaling everything based on a center of scale, no? This is not working really well. How we can scale each polygon on its own center? I just said we need to find the center of each polygon so it scales in its own position. So we have multiple polygons, we need to find the center. Center doesn't exist by defect like here. This is a plugin. It's always in the component area. The component area gives us the center of each polygon. It's slightly silly, but this component is inside another component. So we have component, area, and we have the centroid, that is the center of each one of the polylines. So we can scale based on their own centers. So I can scale by not moving the components in the Z. What I can do now? I can scale with a different factor. How many factors we want to scale? What happens if I connect, for example, 5 here? I'm going to connect 2. So the first, sorry, it's too much. So the first line is being scaled by 0.8, and the other ones by 2. Why? Because there's no more data for the last one, so it's repeating the last component. So we want to have different scaling values for each one of them. We want to scale by creating a what? The same as we create a series of scalings, a series of numbers. We want to create a series of numbers that are going to work as the scaling factor. So let's, for example, create a series of numbers that, in this case, if we connect, we want to state how many we want to have. We need to have the same amount of series of numbers than polygons. So one way will be to list the length. So we want to know the amount of lines that we have. We have 10. We want to have 10 numbers. 10 numbers, and we scale. So what this component is in red can or not scale by factor 0. Okay, of course, if you scale by 0, it's nothing, it doesn't exist. That's why it's making this error. So the first number needs to be, for example, 1 or 0.5 or whatever. Actually, it doesn't matter, the number that you state. So the first number can only be scaled by half. Right now it's growing too aggressive, it's growing too huge. Let's reduce the tilting angle. Let's have scalings with small factors. For example, 0, 1. So right now, if we hide everything, well, let's keep the original one. So right now, we are scaling by 0.4, 0.5, 0.6, 0.7, 0.8, 0.8, 1, 1.2, etc. And we see the original polygon on the bottom. Do you understood this part? We are scaling with a different scale factor for each one of the polylines. Yes? Now let's do the same with rotation. We want to rotate the first one 5 degrees, the second one 10 degrees, the third one 15 degrees, for example. Let's do the same. So it's rotate. We want to rotate these geometries. On what? We need the center of rotation. Again, we do the same. Area to get the center of rotation. And we want to state the angle of rotation. We want to rotate, let's say 5 degrees. So I want to create a series of numbers. The first one is going to be, is not going to rotate. I want to rotate 5 degrees, for example. So the first element is going to rotate 5 degrees, the second one 10, the third one 30, etc. How many? The same amount of geometries. We can state another list length to measure the total amount of lines that we have. Even if we have it here, we can reuse the same component. I'm just repeating the component so to don't mess up a lot the script. But we could actually take the input from here one and connect it here. Okay? But I'm just repeating the component. And we rotate. What happened? These are angle. This is degrees. And here we need radians. So we need to transform this into radians. We input degrees and it gives us radians. So now we have rotated a little bit the geometry. We can easily change the rotation and twist the base by increasing the rotations, for example. Now that we have created this, what we can do? We have a list of polylines. So what we can do is loft them, like the same as you have in any kind of other geometry. So you loft, and you have your geometry. The good point is that you can change. I'm going to make it big. This one is the amount of scaling, the amount of rotation, and the amount of and the height by the amount, changing the account. Why? Right now, our movement we have created how many? We have created 10. That depends on the series. If we change the series to 50, the geometry grows automatically. Why? Because everything is automatically updated, because each time we create more elements, we are also measuring and automatically updating the amount of scalings and the amount of rotations. So it doesn't matter if we make our geometry larger by creating more rotations. If we just keep going to create more movements, the geometry will still be updated. It doesn't matter if I change the growth pattern, for example, to, I don't know, I'm gonna delete this slider because it's too small. Okay, between 0, okay. I can easily broaden it and make a parametric base, or I can change the rotational angle really easily. So the point for the rest of the class, this the more or less half an hour that we have, is this is how we have created the script that is in the here. Grow, scale, rotate, surface. That is the script that you have here. But this one, you see, is growing big and then small. Why? Because we have introduced something that is called graph mapper. So the point of the rest of the class is that you go and you try to produce this geometry without copying this, obviously, that to find a logic on how to modify this script, the one that we just did, to make it big and then small. And maybe to rotate in one direction and then in the other direction, because right now we are rotating just in one direction. So, Sandy, you want to create the breakout rooms?
They are already created, the same as last day, but it's
Before you go into breakout rooms, this is, I'm going to go inside each breakout room and help you.
maybe
Why we don't use the
breakout rooms, proper breakout rooms,
mm-hmm.
because then they can move from one to the other one if they want.
Okay.
But anyway, something that maybe we can do today really different is the ones that they are quite behind because maybe you are really lost. Maybe you can put all of them in the group.
Come here, just everybody in the same group.
No.
I'm assuming that there will be like people that kind of follow the class and they wanted to explore a little bit more, okay, with the challenge that you give. But probably there's another people that is basically struggling to understand the basics.
Troubleshooting.
So maybe you can put that people in another group altogether, and
Okay.
then you can try to spend more time with them, like trying to reinforce and the concepts. What do you think, guys?
I think that's a good idea.
So okay, so who wanted to try the new challenge, let's say, or the new script that they do?
No worry, Veronica.
Yeah.
Like, this challenge is not just to make it feel dumb at all. It's like to check if you can find a logic. I will help you to find that logic. Okay.
Yeah, me too as well.
Sorry, Josefina, could you repeat, please?
Santi, I don't know which for the challenge would be the group.
I mean, let's do it simple. The ones that you wanted to reinforce basic concepts, go to the club 01. The other ones, you can split from club 2, club 3, and club 4. And my suggestion is, if there's someone in the class that already knows Grasshopper a little bit, please split in the don't put like all together. So try to put like in the club one in the club 2, another in the club 3, another in the club 4, because then you will have the other ones. Okay, is it clear?
Yep. Thank you.
And I will give you access, because I think so you need access to enter to the club. I don't know, just tell me.
So where?
So the ones that wants to take part of the challenge go to club 2, 3, and 4. The one that are completely lost and doesn't know how to even switch on Grasshopper, go to club 1 and it will do a little bit of troubleshooting to try to understand key points.
Perfect. Thank you.
Oh. So I'm gonna go to the other session, okay?
Guys, how's it going? Maybe some of you can share the screen. I cannot share my screen because I'm using another computer for that.
Santi, I'm waiting to enter one of the rooms.
Oh, which one?
2.
Wait.
Hola? Do you hear me?
Yes.
Okay, perfect. Thank you. You have any questions of today's class? I know, like, it's not that straightforward, especially with just 2 sessions of Grasshopper. Everything was crystal clear. Hello.
Hello. Edu, what are you doing with the camera?
Hello.
Edu, just for you to know, I asked the ones that there was in the group 2
To Miro, yeah, I can.
just to share. I don't know if they will share or not, but no, probably no.
Okay, they are sharing the things. Okay. Okay. It's a good idea.
I did this solution, but I think it's the ugly one. I like it more the idea of trying to use a function for the lists, but I wasn't able to do it.
Roger, are you speaking? We hear you really, really low.
Yeah, I'm speaking.
Almost couldn't hear you.
Hello?
Yeah.
Now?
Oh, no, it's... So we can hear you, but far away.
I don't know. It's
Oh, don't worry.
better.
Can you also paste the result, like the result of the shape?
Yeah.
And I think so, Clement, is it Clement? Yeah, Clement, you already like get the solution, isn't it? Clement is playing with Grasshopper. It's not anymore with us.
Sorry, I was on the Google Meet and not on Zoom. Yeah, I've got something. It's not perfect, but I'll try to share it on the Miro.
Yeah.
Os oigo muy bajito.
Yeah, me too, Edu. Don't worry.
I have pasted the solution. I got the results. Sorry, on Miro.
Grasshopper Jose is a really classy solution. Jose Uribe, I understand that you have already used Grasshopper before, no?
Me, no. Actually, no. Why?
No? Is the one that is in Miro that right now you have tag also the names, no? Numbers.
No, I haven't posted mine yet.
Is this screenshot the ones I'm selecting? Who's this? It says Grasshopper Jose, file Jose.
I don't know, might not.
I think it's Josefina.
Oh, yeah.
This Miro is fun. This Miro thing.
Hey, from who is the ones that is, let's say, that one? I don't know, the ones that is inverted or something like this, kind of a shape that goes inside itself.
It's mine, but it was a totally random result. I wasn't looking to do that.
Very nice, very nice.
The one that has the peak in the middle, no?
Yeah.
Yes.
Ines with.
Like the point of this like part of the class, the second part is like that you stop being afraid and you try and mess up the things. That is certainly the only and the best way to learn. But it's nice. I like it. I like the shape. Unexpected results. Those are the best ones.
Okay, is missing someone else to share the results? Is it missing someone else? Clement.
Hey, Santi, I'm really struggling to capture what I did. So maybe once I'm able to get it, I'll send it to you guys. But I'm a
Yeah, or
little
just
all over the place now.
yeah, don't worry, or just like paste it here when you have time. Let's say
Mhm.
until the next session. Don't worry. Edu, do you want to say something else? Because it's 2:10. We
Yeah,
already start a little bit with late, but we should like try to
close up.
on time.
Yeah, I was checking the scripts. It's nice. Like, I know, guys, that this is hard. Like, if it's the first time you touch this kind of software, it's quite hard. And and I can repeat and go as low as you want, as many times. We can spend like the whole year of make clubs doing the just one script and repeating again and again and again. But you need to try to practice a little bit on your own. It's the best way, and that this part, the last part of class, just was for that. So kind of catches you a little bit. Hey, what happened if I try to merge this component and upload this other component? As the last class in the first link class, like repository, you still have other scripts that we didn't touch yet today. For example, this one, that you can go and try to understand what's the logic behind it. We will go like displace geometry in connect and extrusion distance. Extrusion distance is really similar to the one that we did last session. You asked me like, okay, can we do the was Grasshopper useful? And we did the Holocaust like museum sculpture of Berlin. We did it in like 1 minute. It works in really similar concept. So now that you know a little bit the basics of everything, of like the basic scripting, it's time to start like trying to produce geometries. Like don't try to get crazy, but just try components and see what happens when you start mixing them. Okay? Like I'm here, if you have questions, you can just send me like issues, asking what this doesn't work, etc. And I can try to help you troubleshoot it. But we can have like 2 year sessions of Grasshopper lessons that if you don't try it on your own, is impossible. Actually, it even happened for me. Like I tried to learn Grasshopper, I think 3 times. I went to like 2 Grasshopper classes, like master courses, but I just attend the classes. And until the last one that I really like say, okay, this is the time I will really start playing and try to make my own scripts. I didn't learn. So basically, I wasted like a lot of time on the first 2 courses because I didn't do it on my own.
One basic question about Grasshopper.
Mm-hmm.
If you're trying to do like a more complex design, for example, that has multiple pieces, would you have like a file for each piece and then bake everything and join them in another Rhino file? Or would you start working all with Grasshopper even you have different pieces?
I usually work in the same Grasshopper file unless it starts becoming really slow. Like really, as long as the computer can keep it, I work in the same file. I just maybe if I'm not using that part of of those components, I just switch them off. But I have everything in the same file. So I try to keep only the part that I'm working right now. But that doesn't mean that the script is not there. You remember you can right click and click disable. That is basically will not calculate it, so it will not take resource of the computer or take time.
And you would bake it at the end when you want to,
Yes.
when you have your final design. Okay.
Thing that you can always bake, and the script still works there. Like you can bake if you want to save it, run a file for some reason, but that doesn't mean that by baking you cannot keep modifying the Grasshopper part.
Okay.
I think that's what was happening to me. My computer was blowing up with Grasshopper.
Yeah, it depends on the type of file, but some plugins, for example, they take like amazing amount of resources. Especially, for example, the point clouds of 3D scanning. Sometimes if you click enable, you need to wait like 30 seconds until calculates the component. So depends on the plugin, you need to be very careful on what you activate and what not. The basic scripts, you really don't care too much. Okay, so if there is no more questions, I think we can have this session considered as finished for today. Next one is going to be again Code Club with Oscar, and in 2 weeks it's going to be the first Grow Club. It's going to be a material-based class. Okay.
Thanks a lot.
Great, thank you.
Thank you.
Thank you. Bye.
Bye-bye.